Hello everyone. So how are you? I hope you are doing well. So today we will start our next chapter, that is acids, bases and salts. So here first we'll try to finish this acid and base, then we'll move on to the salts. So first question is, what is acid and what is base? So from your earlier classes, you all know that acids are sour in taste and bases are bitter in taste. For example, your lemon. Lemon is sour in taste because it contains citric acid. And your soaps, which are bitter in taste because they contain base. Now, imagine if I am giving you an unknown substance and asking you to determine its nature, what you can do? How can you determine the nature? Nature means whether the given substance is acidic or basic. Will you taste it? Never do that. It's very dangerous, really dangerous. Why? Because there are so many acids which are corrosive in nature. If you are tasting them, it will be your last time. So never ever taste any unknown chemical. It's really dangerous. So what else we can do to determine the nature? So there is one thing that is known as indicators. We can use them to find out the nature of a substance, to find out whether a given substance is acidic or basic. So what is indicator? Now coming to the indicators. So indicators are chemical substance which helps us in determining the nature of a substance. Nature means whether a given substance is acidic or basic. So these indicators change the color in different medium. Different medium means in acidic and basic medium. You can have two types of indicators. Natural indicators and synthetic indicators. In natural indicators, we have turmeric, we have litmus, and in synthetic indicators, we have methyl orange, and phenolphthalein. And there are so many, but here in this chapter we have to discuss only about these two indicators. Okay, so turmeric, it's yellow in color, and in acidic medium it retains its color, but in basic medium it's changed its color from yellow to red. So I am writing these indicators color in different medium. In acidic medium, yellow only, and in basic medium, turmeric will change its color into red. What about litmus? So litmus is purple in color, and in acidic medium it's red in color, and in base it's blue in color. Correct. What about methyl orange and phenolphthalein? So methyl orange in acidic medium shows red color, and in basic medium it's so yellow color. So there is a trick to remember the color of methyl orange in different medium. My apple is red and banana is yellow. So my means methyl orange, apple acidic medium, it's red, so its color. Banana base, it's yellow, that is its color. Simple, no? My apple is red, banana is yellow. Simple. Now coming to the phenolphthalein. So this phenolphthalein in acidic medium, phenolphthalein is colorless, and in acidic medium it does not change its color, it's remain colorless. And in basic medium it's changed its color from colorless to pink. Simple. There is one more types of indicator. Those are known as olfactory indicators. So what it means by olfactory indicators? So this word olfactory, it means related to nose. There is one more thing in your book, blue litmus and red litmus. So what it means by blue litmus and red litmus? So litmus is originally purple in color, but when we take this litmus in basic medium, it's so blue color, and that solution is known as blue litmus solution or simply blue litmus. Okay, and when we add base into blue litmus, it won't change the color because it's already in basic medium. So blue litmus does not change its color in basic medium, but in acidic medium it's so different color. It changes its color from blue to red. Understood, no? So blue litmus in acidic medium, it's change its color from blue to red, and in basic medium no color change, means it will remain as blue, no color change. Same is true for red litmus also. So red litmus means our litmus is in acidic medium, and when we add acid in red litmus, it won't change the color because our solution is already acidic. So in acid, no color change, and in base, if you put red litmus into base, it will change the color red to blue. Simple. So we can identify or we can determine the nature of any substance with the help of indicators. Understood? So students, we know the taste of acids and base. We know how to identify the acid and base, but still something is missing. We don't know why acids are acidic in nature and why bases are basic in nature. What is responsible for the acidity? What is responsible for the basicity? So now let's try to find out the answer why acids are acidic. So there is a very common and very interesting reactions of acid. Acids react with metal, active metal, forms salt plus hydrogen gas. So this metal is active. You can take any metal which is above the hydrogen in reactivity series. So if your metal is above the hydrogen in reactivity series, then it reacts with any acid. You can take any acid. It reacts with acid, forms salt and hydrogen gas. Let's try to understand with one example. Okay, so I am taking HCl here. If I am using Na, it will form NaCl and hydrogen gas. We can take H2SO4 also. Again, it will form Na2SO4, that is again salt and hydrogen gas. You can take any other acid also, CH3COH. It will form again salt and hydrogen. Now here you have a question. My question is, from where this hydrogen is coming? Is this coming from the metal? No, metal doesn't have any hydrogen. So from where this hydrogen is coming? Acids. So one point is clear from here, that acids contain hydrogen. Yes? So can we say that hydrogen is responsible for the acidity? So if a substance contains hydrogen, that must be an acid. Can we say that? Is it true? No. Why? Because there are so many compounds, there are so many substances which contain hydrogen, but still they are not acids. For example, do you know what it is? This is sugar that we eat, table sugar. Okay. So if hydrogen is responsible for the acidity, then sugar must be a super acid because it contains 22 hydrogen, but sugar is not acidic. So hydrogen is not responsible for the acidity. So what is responsible for the acidity? H positive ion. H positive ions are responsible for the acidity. All acid produce H positive ion. So HCl, H2SO4, CH3COH, they all produce H positive ion in water. Your sugar, although it contains 22 hydrogen, but it does not produce H positive ion in water. Now you may ask a question that how do we know whether our sugar is producing H positive ions in water or not? So there is a test. We can check by that. What is that test? Just take sugar solution, that means sugar in water, and try to pass the current. So we have battery and here we have bulb. In the case of sugar solution, you will observe that this bulb will not glow. But when we take HCl solution, so this is our HCl solution, that means HCl in water, and this is our sugar solution. In this case, bulb will not glow, but in this case, bulb will glow. What does it mean? It simply means that this sugar solution is not conducting the electricity, but HCl solution is conducting the electricity. So what is responsible for the conduction of electricity? Ions. As you all know that pure water does not conduct electricity. It's not a good conductor of electricity, pure water. But when we add salt into it, it becomes good conductor. So ions are responsible for the conduction of electricity. And as you can see here, sugar is not conducting the electricity. That means there is no ions at all. And HCl is conducting the electricity. That means there are ions. What ions? H positive and Cl negative ion. HCl is breaking into H positive and Cl negative ion. But sugar, it does not dissociate. It will not dissociate. So there is no ion. Is it clear? So acids produce H positive ion in water. So if someone asks you what is acid? So acids are substance which produce H positive ion in water. And similarly, base are substance which produce OH negative ion. So I am writing here acids H positive ion in water, produce H positive ion, produce H positive ion in water, and base are substance which produce OH negative ion in water. Is this clear? So what is acid? It's very simple. Acids are substances which produce H positive ion in water. So H positive ions are responsible for the acidity, not hydrogen. There are many substances which contain hydrogen, but they are not acid. Because H positive ion is the main factor which decides the acidity. Understood? Now one more thing. I am saying H positive ion in water. Imagine if we doesn't have water, then our acid won't work as acid. It won't show acidic nature. Why? Let's try to understand that. So HCl, it can break into H positive ion and Cl negative ion in the presence of water only. If we don't have water, this reaction won't happen. This HCl will not break into H positive ion and Cl negative ion. So to break HCl, we need water. And many times students have confusion with H positive and H3O positive. So they don't know what is the difference between H positive and H3O positive. So these two are same only. The idea is same. Either you can write H positive or H3O positive. Generally we write H positive, but in reality H positive ion does not exist in water. It always reacts with water and form H3O positive ion. So technically this one is more correct. But you can write H positive also, there is no problem. Understood? Now you know the difference between H positive and H3O positive, correct? So H positive ions, they does not exist in water. They react with water and form H3O positive. So if I am writing H3O positive, that means H positive ions are there. Is it clear? So acids are substances which produce H positive ion in water. So water is very necessary, because if we don't have water, then our acid will not be able to produce H positive ion, and if it's not producing H positive ion, it won't show acidic nature. It will not change the color of litmus. Is this clear? So students, what is acid? Acid is a substance which produces H positive ion in water. Simple. So H positive ions are responsible for the acidic nature, not hydrogen. H positive ions are responsible. There are many compounds which contain hydrogen, but still they are not acid because they don't produce H positive ion in water. So H positive ions are main factor for the acidity. Now one more thing, I am saying H positive ion in water. Why water is important? Imagine if we don't have water, then our acid won't work. It will not show acidic nature. It will not change the color of litmus paper. Why? Let's try to understand that. So if you have HCl, HCl is an acid because it produces H positive ion in water. Now if you don't have water, if we have just HCl, then this HCl won't produce H positive ion. It won't break into H positive ion and Cl negative ion itself. We need water here. So water helps in breaking of HCl and forms H positive ion and Cl negative ion. So water is very important here. Water is necessary. Without water, HCl will not break and it will not produce H positive ion, and if it's not producing H positive ion, it is not an acid. Is it clear? Now one more thing, many of the students have confusion between H positive ion and H3O positive ion. In your book, you'll find H positive also and H3O positive also. So what is the difference between H positive and H3O positive? So this H positive ion actually does not exist in water. It always reacts with water and form H3O positive. So it's always better to write H3O positive. This one is more accurate. But there is no problem if you are writing simply H positive ion. But you should know what is the difference between H positive and H3O positive ion. So if you are writing H positive ion, so we are assuming that H positive ion in water will exist in the form of H3O positive ion. Is this clear? Now here I have a question for you. Imagine you have two acids and now you have to check which acid is more stronger. You have to check for the acidic strength. How can we check the acidic strength of two acids? Can we use indicators? No, we can't use indicators because indicators can only tell us whether a substance is acidic or basic. It will not give you any idea about the strength, how much strong is a particular acid. So what else we can do? So there is a substance that is known as universal indicator. What is universal indicator? Universal indicators. So this universal indicators show different color in different H positive ion concentration or for different amount of H positive ion. Universal indicator is a mixture of different types of indicators. If your acid is very strong, it will show dark red color. If your acid is weak, it will show light red color, and accordingly for base also. So we can use universal indicator if we have to check the acidic strength. Understood? Now this universal indicator can only tells you about the strength, but if you have to check the strength quantitatively, means how much strong is a particular acid than other one, so we need to check the pH. What is pH? So pH calculate the H positive ion concentration. So pH. So formula for pH is minus log H positive ion concentration. So what it means by H positive ion concentration? What it means by H positive ion concentration? So what is concentration? So concentration is amount of a particular thing. So if I am saying concentration of H positive ion, that means amount of H positive ion in the solution, not directly amount. So concentration is actually means number of H positive ion per unit volume. I am saying per unit volume. How many H positive ions are present per unit volume, that is known as concentration. Understood? Number of H positive ion per unit volume. Is this clear? So if you have large number of H positive ion, if your acid is producing large number of H positive ion, that means it's a stronger acid. Clear, no? Because it's producing large number of H positive ion. So I am writing stronger acid produce large H positive ion. Simple. And weak acid produce less or low amount of H positive ion. So if your acid is stronger, it will produce large H positive ion. And if H positive ion concentration is more, if there are more number of H positive ion per unit volume, that means concentration is high. And if concentration is high, pH should be higher? No, it should be lower. Why? Because if this term is high, if this term is big, we have negative sign here. So its value will be less because negative sign is there. So if you have high H positive ion concentration, pH will be low. So for stronger acid, larger H positive ion, but pH is low. pH is low. So always remember, if pH is low, that means your acid is stronger. And if you have weak acid, that means low H positive ion concentration. So low H positive ion concentration, we have negative. So negative overall pH will be higher than the stronger acid. So pH is high for weaker acid. Is this clear? So two things are there: pH and strength. If pH is high, acid is weak. If pH is low, acid is stronger. Understood? Now, so here I have a question for you. Imagine you have a acidic solution and you are adding water into it. What will be the change in the concentration of H positive ion? Now you have to be careful here. I am saying we are adding water into the acidic solution. That's very dangerous because it can explode the beaker. So better to add acid into the water. So now I am changing my question. We are adding acid into the water. What will be the change in the concentration of H positive ion? Will it increase or will it decrease? So what is concentration? Concentration simply means number of H positive ion per unit volume. Clear? This is our HCl solution, initial solution. Okay. So now imagine we have 100 H positive ion and volume is 1 liter. So there are 100 H positive ion in 1 liter. Now on addition of water, volume will increase. So now we are assuming that we are adding 1 liter water. So now volume is 2 liter. And what will be the H positive ion concentration? Or what will be the H positive ion amount? Number? 100 only. Clear? So in the first case, 100 H positive ions are present in 1 liter. In the second case, 100 H positive ions are present in 2 liter. In which case concentration is more? First case. Here concentration is high. In 1 liter you have 100 ions. In this case, in 1 liter you have just 50 ions. Now these 100 ions are divided into 2 liter volume. So in this case, in 1 liter solution you just have 50 H positive ion. So this solution is known as dilute solution. This one is dilute solution. Dilute. And this one is concentrated. Why concentrated? Because there are more H positive ion per unit volume. So when we are adding the solvent, or you can say water, the concentration is decreasing. Number of H positive ion per unit volume is decreasing. Is this clear? So this thing is known as dilution. Dilution means addition of water. So in dilution, always concentration decrease. So if concentration is decreasing, pH should increase. If concentration is increasing, pH should decrease, because there is negative sign. Okay, so I am writing on dilution, concentration decrease, pH increase. This is for H positive ion. Same is true for OH negative ion. If we have base and if we are adding water into the base, then concentration of OH negative ion will decrease. So students, we know what is acid and what is base. We know how to detect these acids and base. We know what is responsible for the acidity and basicity. And we know how to compare the acidity and basicity of different acids and base. Now we'll see how to convert these acids and base into some other substance. Now we'll try to make some new substance from our acids and base. First we'll try to prepare hydrogen gas from the acids. Why hydrogen gas? Because there are so many uses of hydrogen. Hydrogen can be used to prepare margarine. What is margarine? It's a cheap butter. Okay. So hydrogen can be used to prepare margarine. It can be used to make fertilizers. It can be used to make fuel cell. What is fuel cell? So it's like a battery that use hydrogen and oxygen to produce electricity. Simple. Okay. Now let's see how to prepare this hydrogen gas from the acid. As I told you before, that acids react with metal, produce hydrogen gas. We will use same reaction to produce hydrogen gas. Is this clear? So, if I have an acid, it reacts with metal, form salt and hydrogen gas. So, in general way I can write acids react with metal, form salt plus hydrogen gas. You can take any acid and you can take any metal as long as your metal is above the hydrogen in reactivity phase. It will always gives you hydrogen gas. Is this clear? So we can make hydrogen gas from the help of acid and a metal. Now next question is, this hydrogen is colorless, it's invisible, we can't see it. So how can we detect this hydrogen gas? So it's very simple. This hydrogen gas, this burns with pop-up sound. Same sound that you hear during the making of popcorn. Same type of sound you will hear while the burning of hydrogen. So if you have to detect hydrogen gas anywhere, just keep a burning candle nearby that. So if you're getting the pop-up sound, that means hydrogen is there. Is this clear? So now everyone can make hydrogen gas. Let's try to make carbon dioxide from our acids. Why carbon dioxide? Carbon dioxide also has so many uses. Carbon dioxide is used in carbonated drinks. Carbonated drinks, Pepsi, Coca-Cola. So this carbon dioxide is used in those soft drinks. Carbon dioxide is also used in fire extinguishers. Nowadays, carbon dioxide is also used to make petrol, or you simply can say fuel. So there are so many uses of carbon dioxide also. Now let's see how can we prepare carbon dioxide. So for that you need a metal carbonates or hydrogen carbonates. What it means? Metal carbonates. So metal carbonates or metal hydrogen carbonate. So carbonate is actually this ion. This ion is known as carbonate. And if I am adding H positive into this, I'll get HCO3. I am adding H positive into this. So this 2 negative will become 1 negative. This is your carbonate and this is your hydrogen carbonate. If some metal ion is also present with this one, then we'll say that is metal carbonate. For example, Na2CO3. So why I am writing Na2? Because charge on Na is +1. So we need to balance the charge. So that's why Na2CO3. In this case, NaHCO3. So this is sodium carbonate and this is sodium hydrogen carbonate. If we have Mg, this is magnesium carbonate. So this time magnesium has +2 charge, so we just need 1 magnesium ion. In this case, I write MgHCO3 twice. This time we need 2 hydrogen carbonate ions. So MgHCO3. This is magnesium hydrogen carbonate. So you can use any of this metal carbonate and metal hydrogen carbonate to produce carbon dioxide. How? We need to make it react with acid. So our acids, for example HCl, they react with this carbonates and carbonate and hydrogen carbonate produce salt NaCl plus water plus carbon dioxide. So we can use this carbon dioxide either for fire extinguisher or to fill our Pepsi bottle. Okay, so now I'm writing in general way that acids react with metal carbonates or metal hydrogen carbonate. So why we are saying hydrogen carbonate? Because in these two there is a difference between just one hydrogen. So in hydrogen carbonate there is one extra hydrogen. That's why metal hydrogen carbonate. Simple. So acid metal carbonate, they react with each other, form salt plus water plus carbon dioxide CO2. Simple. Let's take one more example. HCl plus NaHCO3. So it's very simple. Cl is going with NaCl. Okay, and this hydrogen is going with this HCO3. So you'll get H2CO3 that will decompose and form H2O and CO2. H2O plus CO2. Same thing is happening here also. Cl is going with Na and this hydrogen is combining with CO3. So CO3 has 2 negative charge. So 2 hydrogen will combine with CO3 negative, 2 negative, and you will get H2CO3 and it will break into H2O plus CO2. H2O plus CO2. Same way you can write this reaction for any acid. If you have H2SO4 plus NaHCO3, so this ion will go with Na, simple, Na2SO4, because sulfate has 2 negative charges and Na plus has 1 positive charge, so you need 2 Na plus ion, Na2SO4, and this hydrogen will go with HCO3, it will form H2CO3 and that will breaks and form H2O and CO2. You need to balance this equation, that's all, simple. So here we have discussed 2 important reactions. First one is how to prepare hydrogen by the acid. So student, how can we make carbon dioxide gas? Can we use metal plus acid? Yes? No. Metal plus acid gives you hydrogen gas. If you want to prepare carbon dioxide gas, then you need acid plus metal carbonate or metal hydrogen carbonate. Now next question is, like hydrogen gas, this carbon dioxide gas is again colorless. How can we detect this carbon dioxide gas? So don't worry, we have a test for the detection of carbon dioxide gas also. What is that test? That is known as Milky test. Let's try to understand that, okay? So to detect this carbon dioxide, you need calcium hydroxide, that is known as slaked lime. And when it's dissolved into the water, when you have solution of calcium hydroxide, that is known as lime water. And you need to pass this gas which is coming out from the reaction mixture, that is supposed to be carbon dioxide, through the lime water. And this lime water is colorless. There is no color. It's like pure water. And when we pass this carbon dioxide from the lime water, a white color appears in the solution. Your solution turns milky. Why it's become milky? Reason is this carbon dioxide is reacting with calcium hydroxide and forming calcium carbonate, and which is insoluble in water and which is white in color. So because of white PPT, your solution is turning white, milky. Is this clear? So using lime water you can detect the carbon dioxide gas. But here you have to be really careful. Why? Because if you pass this carbon dioxide in excess amount, then this CO2 can dissolve the calcium carbonate. This CO2 can react with calcium carbonate and can form calcium hydrogen carbonate, which is soluble in water. So if you are passing the excess amount of carbon dioxide, this milky color can again disappear. How? This CO2 can react with calcium carbonate and form calcium hydrogen carbonate, which is soluble in water. So your white color can disappear if you pass the excess amount of the carbon dioxide. Is this clear? Now coming to the next reaction, your acids and base can react with each other. They can neutralize each other effect. What it means? So students, acid seems to be dangerous. Yes? No. Not all acids are dangerous, but most of the acids are dangerous. But please don't afraid of these acids. Why? Because if something bad happens, then also we have solution for that. What is the solution? So we have a substance that can destroy your acid. What is that? That is base. Bases are the enemy of acids. They can destroy the acids. They can neutralize the acid. They can nullify the effect of acid. And same is true opposite way also. If you have base, you can destroy the base with the help of acid. So acid and base are enemy of each other. Understood? Let's try to understand with one reaction. So if you have HCl and you want to destroy this HCl, you can use NaOH, and here you will get NaCl and water. These two are not dangerous. We can even eat them. No, NaCl, and we can drink water. So these are not dangerous. These two are dangerous, and we can destroy them with the help of each other. Understood? And this reaction is known as neutralization reaction. Neutralization reaction. So what is neutralization reaction? So neutralization reaction is the reaction of acid with base, and here we get salt plus water. Simple. Now coming to next reaction. If we have metal oxide, what is metal oxide? You just need a metal, and with metal you have oxygen, that is known as metal oxide. For example, MgO, Na2O, okay, and this metal oxide, when they react with acid, they form this is Mg, not Na, MgCl2 plus H2O. You need to balance this, so let's balance. Now balance everything, okay, and here also NaCl plus water. If you want to balance, you can balance it to its balance. So this is the reaction of metal oxide. This is also metal, sodium is metal, and this is oxygen, metal oxide with acid. What we are getting here? NaCl, MgCl2 plus water. What is this? NaCl. What is this? Water. What is this? This is acid, and this should be base. This should be base. Why? Because as we know, acid and base react with each other, form salt plus water, and here also we are getting salt plus water, and this side we have acid, so other substance must be a base. So metal oxides are basic in nature, they are base. Understood? So I can say metal oxides are basic in nature, and they react with our acids, forms salt plus water. So I am writing metal oxides react with acids. You can use another acid also. You can use H2SO4 also. You can use HNO3 also. You can use phosphoric acid also. You can use acetic acid also. It's your choice. So metal oxide, they react with acids, form salt plus water. Simple. Now what about non-metallic oxide? Non-metallic oxide? So you need a non-metal, and with that oxygen. So carbon is non-metal, no? Yes, carbon is non-metal. So CO2, this is a non-metal oxide. Carbon dioxide, this is oxide, and this is the oxide of non-metal. So this is our non-metallic oxide. If it's reacting with, what is this? This is our base. Calcium hydroxide is base because it produces OH negative ion in water. So calcium hydroxide, slaked lime, it's our base. It reacts with carbon dioxide, form calcium carbonate plus water. This is our base. This is water. This is salt. Okay. This must be acid plus base, salt plus water. What is missing here? Base we have acid. So what I am trying to say, these non-metallic oxides are acidic in nature. Non-metallic oxides are acidic in nature. You will study about this metallic oxide and non-metallic oxide in more detail in the next chapter. So don't worry. Just remember two things. Metal oxides are basic in nature, and non-metallic oxides are acidic in nature. So if non-metallic oxides are reacting with base, they will form salt plus water, and metallic oxide, if they are reacting with acid, they will form salt plus water. Simple. Now coming to the salts. So student, please tell me, what is salt? NaCl, our normal table salt. Yes, that's the obvious answer. If you ask anyone in your neighborhood for salt, they will surely give you table salt. Correct? But most of the people don't know that there are so many types of salt in our universe. Correct? No? So if you are a chemistry student, you should know that there are so many types of salt in addition to normal table salts. Now question is, how can we define the salts? So salts are the family. Salt is a family of compounds, just like acid. We have so many different types of acid, no? Similarly, we have so many different types of salts. Now, how can we define these salts? It's very simple. So, salts are the compounds that are formed from acid and base reactions. Substance that we are getting from the acid and base reaction, those are known as salts. Is this clear? For example, NaCl, Na2SO4, NaNO3, MgSO4, Na2SO4, and so many are there. So if I have to explain this NaCl is coming from the NaOH plus HCl reaction, acid and base reaction. Na2SO4, it's coming from the NaOH plus H2SO4. What is this? Base acid. NaNO3 is coming from the NaOH plus HNO3. MgSO4 is coming from the magnesium hydroxide. This is again base plus H2SO4. Na2SO4 is coming from NaOH plus H2SO4. So you can produce large number of salt with the help of different acid and base. So when acid and base react, they form the salt. Is this clear? So if someone asks you what is salt? So salts are compounds, not just one compound. There are so many compounds. Salts are compounds which are formed from acid and base reaction. Those are known as salts. So what is the pH of salt? Are they neutral? No. Salts can be neutral also, they can be acidic also, they can be basic also. It's depend upon what type of acid and base are reacting. From where you are getting the salt, it's depend upon the acid and base. If you have strong acid plus strong base, like in this case, the salt that you are getting from here, that will be neutral. The strong acid can neutralize completely this strong base. So in this case, you will get the neutral salt. Okay. Now, there are possibility that you are reacting strong acid with weak base. Yes. Yes, that is possible. And in this case, weak base will not able to neutralize acid completely. So your salt will be acidic. Acidic salt. You will get acidic salt in this case. So acidic salt means, so in this case, if your salt is neutral, pH should be equal to 7. And in this case, pH should be more than 7. No, less than 7. pH is less than 7 for this acidic salt. If your salt is coming from the strong acid and weak base. Now there is possibility we are using weak base plus strong acid. No. This is the same thing. So weak acid plus strong base we can use. In this case, this acid will not be able to neutralize the base completely. So our salt should be basic. In this case, pH will be greater than 7. Simple, no? See, if your component means if your acid or base is weak, then the salt will be the stronger part. Like in this case acid is stronger, so that's why our salt is also acidic. So stronger part will dominate. In this case also we have strong base, so our salt is basic. If both are stronger, then they will neutralize each other. So your solution will be, your salt will be neutral. So student, our table salt seems to be boring, but it is very important raw material to prepare various daily life products. Have you heard about NaOH, sodium hydroxide? Yes. So sodium hydroxide is used in soaps and detergent making. It is also used in paper industry, and it is also, your NaOH, it is also used to clean the metal surface, means degreasing the metal. So there are so many uses of NaOH, and we can prepare this NaOH from our boring NaCl, table salt. How can we prepare this NaOH from the NaCl? Let's try to understand that. Okay. So for that we need a brine solution. What is brine solution? So NaCl dissolved into water, that is known as brine solution. So you have to pass the electricity from the brine solution. So here we have our brine solution, and here we have two electrodes through which we are passing the current into the brine solution. So these electrodes are connected with the battery. So this is positive end and this one is negative end. So positive, this electrode is positive electrode, and this one is negative electrode. So what it means by electrode? So electrodes are metal rods through which current can pass. So any material rod through which we can pass the current, that is known as electrode. So these are our electrodes. These are conductor of electricity. Simple. Now in our brine solution we have Na plus ion, because NaCl, if it's dissolved into water, it will break into the ions. So Na plus ion, Cl negative ion. And what else? H2O can be in the form of H positive and OH negative ion. Is this clear? So when we are passing the current, these ions will move towards the oppositively charged electrodes. So this electrode has positive charge. So on this electrode, negative charge will migrate, negative ions will migrate. So here in the solution you have two negative ions, OH negative ion and Cl negative ion. And on negative electrode, positive ions will migrate. Na plus ion will migrate towards negative electrode and H positive ion will migrate towards that. Then when they are moving towards the electrode, when they come near to the electrode, then discharge will happen. What it means by discharge? So at this electrode, at positive electrode, Cl negative and OH negative ions are coming. And positive electrode means there is deficiency of electrons. Positive means deficiency of electron. So this electrode will take out the electron from any of these two negative ions. And it's depend upon the ion which will give the electron first. Which one have more tendency to give the electron. So out of Cl and OH, Cl negative ion has more tendency to give the electron. So Cl negative will give its electron and form Cl2 here on this electrode, okay? But OH will remain into the solution. Is this clear? Now coming to the another electrode, here H positive and Na plus are going. So this time this electrode has excess number of electrons. Because of that there is a negative charge. Is this clear? So this electrode will give electron to the any of these two ions. Now it's depend upon the ion which is easily take the electrons. So out of H positive and Na plus ion, H plus will take electrons easily. So H plus will take the electron and form H2. Is this clear? So this electrode is known as anode and this one is known as cathode. Why anode? Anode means where oxidation occurs. So on this electrode oxidation is occurring. This is oxidation, loss of electron, and this one is gain of electron. So this is reduction. So this reaction will happen where? At the cathode. Simple. And this one is anode. Now in the solution what you have? You have Na plus ion and OH negative ion. So they both will combine and form NaOH. So overall reaction is NaCl plus water, and if we are passing the electricity, we'll get NaOH and hydrogen and chlorine, because this Cl negative ion is converting into Cl2 and H positive ion is converting into hydrogen. Simple. And this reaction, this process is known as chloro, because chlorine is producing here, alkali, because NaOH is our alkali. So chloro-alkali process. So using this process we can prepare NaOH. Is this clear? Now here we are getting the chlorine also. So this chlorine we can use to prepare bleaching powder. What is bleaching powder? We'll see just in a few minutes. Now coming to the bleaching powder. So what is bleaching powder? COCl2. This compound is known as bleaching powder. What is the name of this compound? This is calcium oxychloride. Simple. Calcium oxychloride. Now next thing is, how can we prepare this calcium oxychloride? So we need a calcium compound, clear, and we need chlorine also, and we need oxygen also. So what we can use here? So for calcium and oxygen we can use this compound. What do you say? Yes, we can use. So what is the name of this compound? Calcium hydroxide, or it is also known as dry slaked lime, and we need chlorine gas. That's all. So you need to pass chlorine gas from the dry slaked lime and you will get the calcium oxychloride or our bleaching powder. In addition to that we will get the water also. Simple. So from NaCl we can prepare the chlorine, and from chlorine we can prepare the bleaching powder. So our table salts is so much useful. We can prepare NaOH also, we can prepare bleaching powder also from that. Now there are so many uses for bleaching powder. Do you know any use of bleaching powder? So bleaching powder is, I'll use another pen. Bleaching powder is used in paper industry. Why? To bleach the paper. Okay. It is also used in textile industry. Why? Again, to bleach the textile. It is also used in laundry. Why? To bleach the wash clothes. Clear? It is also used in chemical industry. As an oxidizing agent. Why oxidizing agent? So what is oxidizing agent? Oxidizing agent which helps in oxidation. How they can help in oxidation? By providing their oxygen. So our calcium oxychloride, our bleaching powder contain oxygen. So it can give this oxygen to another compound. So it helps in oxidation. That's why it is used in chemical industry for oxidation purpose. It is also used for disinfecting water, drinking water. Is this clear? So we use this bleaching powder in paper industry, textile industry and laundry for bleaching. So what it means by bleaching? So bleaching means removing of color substance from a material. So bleaching powder can be used to remove the color substance from a material, whether it's your paper or whether your textile or your clothes. So that's why bleaching powder is used in these three industry for the bleaching purpose, to remove the color substance from the material. Is this clear? So student, have you heard about baking soda? Yes. What is baking soda? NaHCO3. This is the formula for baking soda, and this is known as sodium. Sodium is there, hydrogen is there, hydrogen, and carbonate. CO3 is known as carbonate. So sodium hydrogen carbonate is your baking soda. And do you know that our normal table salt, boring table salt, is used to prepare baking soda? How can we prepare baking soda from our normal table salt? Let's see. So for that we need NaCl plus water. That means brine solution. Then you have to pass carbon dioxide from the brine solution. Then you have to pass ammonia gas also from the brine solution. And then you will get the NH4Cl plus NaHCO3. Now how you are getting this product? Let's try to understand that. Okay. So this H2O and CO2, they both react and form H2CO3. It's an acid. H2CO3 is a weak acid, and NH3, it's a base, so they both will react with each other. Your acids always gives H positive ion, correct? And that H positive ion will be taken by NH3. So H2CO3 will lose one H positive ion, so it will form HCO3, hydrogen carbonate ion, and H positive ion will be taken by NH3, so it will become NH4 plus ion. Something like hydronium, H2 plus H plus form H3O positive, no? In similar way, if we have NH3 plus H positive, it will form NH4 plus ion. Simple. So NH3 is taking that proton and forming NH4 plus ion, ammonium ion. Now in the solution you have Na plus ion also and Cl negative ion also. So Na plus ion will combine with HCO3 and Cl will combine with the ammonium ion. NH4Cl, NaHCO3. Simple, clear? Now there are so many uses for baking soda, and there is only one reaction on which all these uses are based. For all the uses, one reaction is responsible. What is that reaction? We have already discussed about that reaction. What is that? NaHCO3 react with acid and form what it form? It form a salt. So salt depend upon the which acid you are using. So I am writing just H positive. So H positive, it means it is coming from some acid. You can have HCl, you can have H2SO4, you can have HNO3 also, any type of acid. So NaHCO3 react with acid, form salt, water plus CO2, carbon dioxide. Clear, no? We discussed this reaction earlier also, that when metal carbonates or metal hydrogen carbonate react with acid, they form salt, water and carbon dioxide. So this reaction is responsible for all the uses. First use is it is used in preparation of baking powder. So what is the difference between baking soda and baking powder? Baking soda is just NaHCO3. Baking powder is a mixture of NaHCO3 plus tartaric acid. Tartaric acid. So tartaric acid is a weak, or you can say mild, and edible acid, means it's not that much strong and you can eat it also. So when baking powder is mixed with water, these two NHCO3, our baking soda and tartaric acid, start reacting with each other and form carbon dioxide. And this produced carbon dioxide is responsible for the rise of cake and breads, and which makes them soft and spongy. Is this clear? So this reaction is responsible for the action of baking powder. Now coming to the another reaction, our NaHCO3 is also used in antacid. So what is antacid? So whenever we have acidity, we take antacid, which can give relief from the acidity. So this antacid contain NaHCO3, baking soda, and this baking soda reacts with the acid which is present in excess amount in our stomach and neutralize the acid. Is this clear? Third is, it is used in soda acid fire extinguisher. So soda acid fire extinguisher means what? Soda means we are using baking soda here and we are using one acid. So when we are opening up the nozzle of fire extinguisher, this soda, baking soda NaHCO3, it reacts with the acid present in our fire extinguisher, produce carbon dioxide, and this carbon dioxide can be used to extinguish the fire. Simple. So table salt can be used to prepare NaOH, it can be used to prepare bleaching powder, it can be used to prepare baking soda. So many uses. Now coming to the washing soda. So what is washing soda? Na2 not H, okay, Na2CO3.10H2O. This is known as washing soda. What is the name of this compound? Hydrated sodium. This is sodium and carbonate. Why hydrated? Because water is there. This is not normal water. This is known as water of crystallization. Water of crystallization. So what it means by water of crystallization? Let's try to understand this. Okay. So as you all know, all salt have crystal structure. They form crystal structure. And when they are forming the crystal from the ions, or you can say during the crystallization process, some of the water molecules trap inside the crystal, and that is, those water molecules are your water of crystallization. So this 10H2O, they are present inside the crystal of Na2CO3. Is this clear? So how can we define this water of crystallization? It's very simple. Fixed number of water molecules associated with one formula unit of a salt. Simple. For this Na2CO3, 10 water molecules are associated. So water of crystallization in this case is 10. For CuSO4, it's 5. For this is your POP, plaster of Paris. For POP, it's half, and for gypsum, water of crystallization is 2. So what it means by half H2O? How water can be half? So half means that 2CSO4 unit, calcium sulfate unit, 2 calcium sulfate units are sharing just one water molecules. So that's why we are writing half here. Is this clear? So in all these cases, water of crystallization is present, and these are known as hydrated form. These are your hydrated form. That means water of crystallization is present there. Now in your book, you will find a heading that, are crystals of salt really dry? Yes, salts of crystals are completely dry. If you try to touch this washing soda, it's completely dry. You will not feel wet. Why? Because this water is there, but that water is present inside the crystal. So you won't feel wet. Is this clear? So this water of crystallization, these water molecules are present inside the crystal. So that's why our crystal is completely dry if you try to touch them. Now next question is, how can we remove this water of crystallization? We have to break the crystal. How can we break the crystal? We have to supply the energy. How can we supply the energy? We have to heat the crystal. Simple. So if you heat the crystal will break and all the water of crystallization will evaporate. Okay. So if you heat this Na2CO3.10H2O, hydrated sodium carbonate, all the water of crystallization can be removed, and then you will get the simple Na2CO3, that is known as anhydrous sodium carbonate. So washing soda is not anhydrous sodium carbonate, it's hydrated sodium carbonate. Is this clear? And do you know this washing soda can also be prepared from our table salt? Yes, not directly but indirectly. From NaCl we can prepare baking soda. So we can get NaCO3 baking soda from our NaCl, and if you heat this NaHCO3, our baking soda, it will give Na2CO3 plus H2O plus CO2. If you have to balance it, just put 2 here. This reaction is balanced. Clear? So now we have anhydrous. There is no water of crystallization. So this is not the washing soda. This is anhydrous. Hydrated means there is water, anhydrous means there is no water. Anhydrous sodium carbonate. But we need hydrated Na2CO3. So what we have to do, just put this Na2CO3 into water and try to crystallize it. And you will get Na2CO3.10H2. Simple. This is the preparation of washing soda. Now there are so many uses of washing soda. This washing soda is used in paper industry, it is used in soap industry, it is used in glass industry too. Washing soda contains sodium atom, so it is also used to prepare sodium compound, used to manufacture sodium compounds. Example is borax. So what is borax? So borax is a compound that mainly used in cleaning agents. It is generally used for cleaning purposes. You can clean furniture from the borax, you can clean the floor also from the borax. So there are so many uses of borax, and we can prepare this borax from our washing soda. Washing soda can be used for cleaning purposes also in our home. From washing soda you can clean your clothes, you can clean your floor, you can clean your utensil, you can clean your window, you can clean your doors. So you can use this washing soda as cleansing agent for domestic purposes. Okay, so it is used as cleaning agent for domestic purposes. And this washing soda can be used to remove the permanent hardness of water. So if you find hard water, with the help of washing soda you can make it soft. Okay, so for removal of permanent hardness of water. So these are the some uses of washing soda. Now our chapter is over.